I'm going to show you how to modify one of these 2.42 inch OLED displays from SPI through to I2C. Now the reason for this is that these displays are pretty much universal, right? The chip that's on them is the SD1306. These can do both if you configure them. Now the problem with these is that information about how to do it is actually hard to find. This particular display I couldn't find any information on at all actually, this particular one. I found other ones which are slightly different, I had to print out on the end instead. There's information on those telling you which resistors to change and that sort of stuff, but nothing on this one, so I thought, right, I better do a video on this then, seeing as no information, I better make it a bit more accessible. So I've already done one display and it works fine, so I'm going to show you how to do another one. So let's have a look at this one. So there's the actual module, get your focus and everything. Right, so there's the module, and there's the rear of the module, and you can see over here you've got a I2C, or 2C as they call it, and SPI resistor. Now that's not the only one. If you look over here you see it says I2C R9, 10, 11, 12, and SPI is R8. So R8 is in place, so it's set up for SPI right now. I actually purchased these as I2C displays, but they've arrived as SPI. Of course they did. So I've got to convert them. You know, the other thing is, well, where are these other resistors? You can't see them. Well, it's got it underneath this flex here. You can just see the resistors under the bottom there. Alright, so they're under there. So let's pop this flex out of the way. So I've popped this flex out now so you can see the resistors. And there we go, you've got R11, R10 and R12 down here. Alright, so that's those other three resistors. Because R9 is over here. Let's pop that back up a little bit. So there's R9 there for I2C, so it's R8, R9 with a shared link there between them. So you have to move that resistor to here and populate these ones. Now the question is, what do you put in there? Well, these two bottom ones link to these pins up here. Okay, so the DC and CS, they link up there, and those are just jumpers. So you just link them to ground, because it's supposed to be pulled to ground, both of those, and that's all those are doing. So you can put 0 ohm resistors in there. As far as R11 goes, I've just done best guess, and I put 0 ohm in there as well. And it seemed to work. So I don't know, I actually don't know what that does yet. I maybe could figure out. So as you can see, it's going to be fairly straightforward. Now these are pretty small resistors. I think they're 0603s. Now when I did the previous display, I put an 0402 on there, and the thing was tiny. I mean, it fits on the pads alright, but it's obviously not the same size as the originals. And 0402 is one to grab, but I thought, well, I'll just chuck one of them on. So I'm going to put 0603s on these ones, and I'm going to use 0 ohm resistors. Now when I did the previous display, I did it twice. The first time I used 1K resistors because I wasn't quite sure what I was dealing with. I wasn't sure if it was going to be pull downs or pull ups, so I didn't want to be shorting supplies out and that sort of stuff. So I used 1K, and it kind of worked, but it's a bit glitchy. So I realised that it's obviously not right. Then I probed around, and that's when I traced these connections out. So these bottom two connections go to these two up here. That's how I found that out, by probing around. As far as what that one does, I'm not sure. So yeah, I should probably demonstrate it actually. Yeah, I should do that. Alright, so here's the module. I've got my EV blog meter here, the BM235 set up, set to continuity mode. Continuity, how you want to pronounce it. So let's probe these to prove to you where these go. Now we've got chip select, and we've got R12. Is that one there? Okay. And DC, which is, I think that's for the coding, something, and that's also to there. Okay. Now the other side is ground, so if we go to the ground pin, which is up here, go, and ground there. Now this one here, R11, that isn't a ground, right? That's a programming line. What it actually does, if I go to the SDA line, which one is it, SDA? Yep. There we go. So that actually connects the SDA line to here. So it sends it through, and it goes up to the module here somewhere. I'm not sure exactly where. The other side doesn't connect to any of these pins. Alright, so yep, see, so that side goes to SDA, so it's linking the SDA line up to the chip. So all we've got to do is fit those links, and we're done. Obviously, take this one here off as well, move that one. So we'll get onto it. So here we go. I've got the thing on the Andon Star microscope, which I've recently acquired for free, thanks to Andon Star. So I thought I'd show you on here. So we've got, these are the resistors we've got to do, just under here. Right, so R11, R10, R12. I wish I actually call them something other than R, maybe L. Well, I can't use L, can use an inductor? Link or something, or jumper. You know, be better than resistor. I mean, 0 ohm resistors are being used as jumpers, but anyway, so there's the other ones there, we've got to change over. So we've got to get the resistor there, move over to that side, and fit those three, and that will then be an I2C display instead of a SPI display. It's nicely nice, it does tell you on the silk screen which ones should be there. It does have this missing capacitor here, C7. I'm not sure why that's not installed. I guess they figured I didn't need it in the end. When I see missing parts, I'm always tempted to put a part in there. just to help it. That's obviously cutting costs, saving themselves 10 cents or something. So what I've got over here is my little sample box, you know, Chinese parts. I mean, it's just resistors, it's not that complicated. I don't have a problem with getting sample books. I mean, the quality, you don't know what you're really getting. You know, what brand are these? Well, let's say Yagio, but are they really? Just don't know. Anyway, I've got some 0 ohm resistors here. We'll get a few of these out and we'll pop them in place and solder them in. Alright, let's get some out of here. Got 3. Just pop on the board. It's going to tend to slide everywhere, isn't it, of course? That's a bit of a pain. But, never mind. There we go, up here. And of course, all of them have landed upside down. It's always fun. Okay, I'll sort this. Okay, I've taped the board down. Got those just to turn around the right way. Let's put a little bit of flux on here just to help hold the parts in place and freshen the connections up. This board's still going to move around a little bit. I'm going to tape down too tightly. Right, let's just freshen these up with some decent solder. By decent I mean leaded. I know some people really hate leaded. I don't. Let's freshen up a little bit. Right, now let's get some resistors in place. This is where it gets a bit tricky because the microscope's kind of in the way. When I did this before, I did it without the microscope. So, it could actually be a little bit harder. Because I'm also not really looking at the microscope when I'm doing it. Now you could use hot air, but I'm worried about heating up the back of the screen. Also don't want to damage the LCD itself. So that's why I'm using a soldering iron rather than hot air. For doing surface mount, I prefer to use hot air if I can, but can't always do that. Okay, it's down. It's not pretty, but it's down. Next one. I'll clean this up afterwards as well. It's a nice perfect placement there. That's good. That'll stay there. I'm going side to side to try and get the thing to bed down on the pads. And one more. Come on, of course it's spun around. I'm actually right-handed, so using tweezers with my left hand is a little bit awkward, but then I tend to hold the arm with the right hand, so you know, can't really win, can you? There we go, done. I'm happy with this first one, it's a bit ugly. Don't think I can move it though. Burn the flux as well. Anyway, it's in place. So the links are on there. So I'm going to move it now. I'll move the other link, which is already in place. The factory one, which is down here somewhere. This one's a little bit tricky because I've got to try and melt both sides of the resistor at the same time. There we go, gotcha. Come on. There we go. Done. Let's clean it up. Put my yarn there. Get my brush. Oh, I haven't got it in hand. Hold on. Let's just take the tape off actually. God, everywhere. Right. I can certainly do a nicer job using hot air, but yeah, I don't want to heat this LCD up as I said. Don't want to get that hot. Yeah, it will do, I suppose. Get the worst of the flux off. Good enough, I reckon. Good enough. Okay, obviously soldered nicely. Well, I wouldn't say no, that's a bit wonky, but yeah. Perfectionism. So that should now work. We'll put the flex back in. Okay, locked up, that's all fine. Flex is slightly wonky, but it shouldn't matter. It's only very slightly off. Should be right. Should it? Oh, let's just tweak it a bit more. Don't like things being slightly wonky. Is that better? Yeah, it's better. Cool. That's it and done. Now, I'll put some headers on this. I'll show you it working. I've got the display plugged in. We'll try it out in a second. I'm confident it will work. I've already used this with my other display when I've already converted, so we'll see how this one goes. What was I going to say? Oh yeah, this is a different orientation compared to the little 0.96 inch OLED displays. Now the 0.96 inch, which is what I based this on, this is actually upside down, alright? So it actually goes this way up, and then the display sat down here. The pinout is opposite, it's actually flipped. Now you can actually flip the display in the software, and I've actually done that, but I've put it back because I'm going to be mounting it the correct way up in the actual final assembly, so it's currently going to be upside down so you can see the display. Okay, let's plug it in, see if it actually works. I know the other display did. And there we go, we have a display. It's working. All good. It works. Success. So that's how you change one of your displays from SPI to I2C. The default I2C address for these displays is 03C, is the default address for these. Just so you know as well. Catch you later. Thanks for watching. If you found it interesting, give us a thumbs up. Share the video if you think people might be interested in knowing how to convert these displays. Make sure you subscribe and click the bell icon, because that's also important. And have a chat down there in the comments. It helps the channel, helps me, helps you. Have a chat. Catch you later. Bye.